All right, everybody. Okay, cool. So here I am again. Hello. I will try to make this a little less painful than the last time, in the sense of less code and clutter. And the theme this time is mutable resources, which is a very mystical theme, of which you only heard vague rumors, I'm sure. And I will try to give an overview of what this is with the help of my favorite mutants. Anybody know who this is, by the way? Hey, there we go. So mutable resources are a predictable way of looking up data in Swarm. Now we all know how this address thing works. Actually, coming to think of it, I explained exactly the same thing a couple of hours ago. So we don't really need to go through all of that. We know that when you hash some data, the hash of that data will become the address of the data that you want to put, and then you find your way to the nearest node matching that data, and it ends up being there, so we know where to look for it. But to guess what this data is going to be is kind of like a whack-a-mole game. It's really, really hard to do. In fact, it's so hard to do that you would have approximately this number of moles, what you can fit in here, and probably even God would have a hard time knowing where to strike. So how can we somehow make this more predictable? Well, we all know that we have something called, is this the right slide? Yeah. We have something called ENS, so you pay for putting a name, a link between the easy to remember name and the chunk address. But of course, this is expensive, you have to pay every time. And it also tends to be a little bit slow, since the average block time, at least on Ropsten, I think is something like 14.457 seconds or so per block. So wouldn't it be nice if we had a better solution? So this is what mutable resources is about. And the foundation of mutable resources is kind of a time pulse. So to use for a reference, we use the block time as a time pulse. And we say that this resource, we will update every so and so many blocks. Now, let's say there is an update on block 42. And we are currently on block 44. Then we could say the next block in the period, if we have one block every 4 blocks, or one update every 4 blocks, will be 46. So we go look for an update at block number 46, but there's nothing. So we go looking in the past one, the one before that, in the frequency that we have set, the block update rate that we've set, and what do you know? There we find our update. Now, conversely, or similarly, if we do happen to have an update on the next period, then we look up to the next period, and we get the resource. It doesn't really sound faster to say that you have one update every 4 blocks. Then just one, yes?
You can run it in parallel.
Pardon?
You can run multiple updates in parallel in the other window. So then you can actually run multiple.
Exactly. So this is kind of what this shows, this slide here.
These blocks, this is Ethereum blockchain blocks you're talking about, or is it something else?
It's blockchain blocks, yeah, definitely, blockchain.
What are you looking at? Looking at some data in a smart contract?
It's not ENS, you're updating ENS names every 4 blocks?
No. Yeah, I guess I should probably explain what these blocks are, maybe, or yeah, would this be easier? Okay, right.
They're all mutants, obviously.
Yeah, all the mutants. I mean, it should be self-explanatory, right? So what we're actually doing is we're creating fake chunks on Swarm. So all of the chunks that are on Swarm currently are content addressed, which means you take the data that you have, you hash it, it creates a deterministic address from that data, and then you send the data out on Swarm, right? So you know, if you want that piece of data that you know what the address is, it will be exactly that piece of data. But this is unpredictable, right? So this was the whole whack-a-mole thing. Now, let's say that we have a scheme where we know exactly if I put this data together with this data and hash that, I can use this as a key with the data I want to store and know exactly what the key is in advance. You can take the block number, let's say a constant pulse of in this case the block number and a version number, and create a key out of this. And then you use this as the key to store on Swarm instead. So let's say I have this period of every 4 blocks, right? I know that the starting block is 42. So when I look up the mutable resource, I get a root chunk information. This includes 2 things. It includes where we start to look, or where the first resource was, and it includes a frequency, a pulse. So the initial data that we have is we start at 42, and for every 4 blocks, we could kind of expect an update. Is this clear? So kind of so far then? Or?
So every 4 blocks, you have a different location in the swarm to look for data. It's not something on the blockchain.
Exactly, yeah, exactly this. So the reason why we use the blockchain is because we kind of have to have a similar timekeeping between all the nodes. So if you use the synced blockchain for this, then everybody will know what block height we are in, and thus which block we should be looking for next when we create this key to look something up. Is this somewhat clear, or? Yeah, good. Right, so as I was saying, every 4 blocks doesn't sound very fast. As you were saying, you can do several in 1 block. So that's exactly what we do here, right? We attach to this one, we suddenly have 3 updates, which kind of can act like version numbers in a way. So now similarly, we would block 57, we look at 59, there's nothing, 54, there's nothing. 50, we find something. Then we start looking, is there a number 2? If there is there a number 3, and so on. And if we don't find any more, number 4 in this case, version number 3.3 will be the latest update of this resource. So, this works as usual. You have the update, you have the node, you do the update, you send your update to Swarm.
Quick question.
Yeah.
The version numbers you chose, were those, in that scheme, those version numbers would be automatically generated?
Okay, so yeah, I need to say that. So initially we saw that the start block is, for example, here 42, right? So instead of keeping these awkward numbers, 42, 46, and whatever it is, this awkward arbitrary numbers, instead we could use period numbers. So the period 1 is the starting block, then 2 will be the next one in frequency, and so on and so forth. So when you choose a starting block and you choose a frequency, then then you can actually use 1, 2, 3, 4, 5, 3.3, 3.4. So this will be the same for any resource that you use. Right. So what happens when you, in principle, anybody could then generate a resource and send it onto Swarm, even on your behalf, right? So let's say you own a domain called mutable.eth, and you start having a Twitter feed, but then suddenly somebody else comes along and starts posting to mutable.eth as well. It's not so cool. Well, it depends on what they write, but if they write something nasty, it's not so nice. So that is why all the updates have to be signed, first of all, and signed by the account that owns the ENS address of the resource that we're updating. And when you try to post, this will be checked against ENS, so that the account on the node that you generate the update from will be then checked the ENS ownership. If it checks out, then you can send the resource. Of course, you can always hack your own node and kind of circumvent this, but other nodes in the network will check this relationship as well. So if you send it to somebody, they will check it. If it's fake, then they will drop it. So it won't propagate in the system. So not currently implemented, but after later on, there will also be issued notification messages or a possibility to subscribe to messages when updates are made using PSS as well to anybody that wants to listen. Obviously, if it doesn't check out with ENS, it won't be sent to Swarm, as you see here, and no updates will be sent. So, shortly, or a short overview of what the API here works. So, to create a mutable resource, so currently only a HTTP API is active. And to create mutable resource, we have a special scheme called BZZ resource. ID would be your ENS name that you want to latch this mutable resource onto. And the frequency would be the pulse of the update. So as we saw before, you start on block so-and-so, and every 4 or whatever, it's the frequency. It will create a resource on the starting block, or on the block height that we're currently on. So that will be your starting block. Now, to update a resource, you post to that same ENS name with whatever data that you want to post. To retrieve the latest update that you did, similarly, you do use just the ID, but you issue a GET instead. You can also retrieve for a specific period. So let's say you want the last version of period 3. If you give one numeric value on the first, after the first slash, it will get the period. And you can also get a concrete period and version as well. So before I describe this, so I realized that to step back a little bit, let's just recollect that this is a scheme that is specifically well suited to kind of replace, or not replace, but take the role of ENS updates in a sense, right? So, there are two types of updates that you can do using mutable resources in the current implementation. You could do raw updates, which is just arbitrary raw data that you can send as updates. But you can also send multi-hash updates, which is swarm hashes. If you give, I'm sorry, but I realized that these slides of the API are actually old. So I will show you exactly how it works on my terminal just in a minute. So there are either arbitrary data updates, which is just verbatim raw data that you send, or you can send swarm hash, in which case the backend will treat it as a hash, and if you issue the normal BCC retrieval of the resource, it will actually show you the page that's behind it. It will resolve the hash that you give it and show you back the page. It resolves it to the latest version, yes. Okay, so let's try an example of this, shall we? So first of all, can you see this? No, you can't. Let's see. So first of all, we kill my data directory so that there is nothing there. And then we start our swarm node. So what we're doing now is swarm node is started up and it's connecting to the open test cluster. Now, up until this morning, it was not a problem to get the updates to show on the test cluster. And this morning, it was lagging very far behind. So probably it will just be sort of a local demonstration, but it's still let's try. So to create a resource, we do, so you can't see that, right? Can you in the back see what's being written down here? It's okay. So to create a resource, we do curl and post, localhost, BCC resource, and we take our demonstration ENS name, live1 mutable test. And as I said, there are two types of updates, right? There are the raw ones and there are the multi-hash ones. So what wasn't shown in my old ancient API slides was that to do a raw update, a verbatim update, you postfix with raw and then frequency number after this. And data might also be a nice thing to have. So now we've created the resource. The first update of the resource is what's in this list HTML file. In this list HTML file is just a small, a couple of list nodes for a HTML page. And to show then how this works is, so which one? Live one? So now the initial update, the manifest that's here, this contains the root information of the mutable resource. So the start block that we had and the frequency, right? Now this one time, we need to put this information into ENS. So we let ENS point to this root hash. So that when we do mutable resource updates, it will go there. It will say, oh, that's the start block. This is the frequency. And hopefully this will work then. Right. So now this is being live1 mutable test is being resolved to this hash that has the mutable resource that says starting block frequency and so on. So let's add an update here, and let's add an update here, and now we've added 3 updates to this resource. We can refresh it, and we get the same. Data back. We can curl retrieve this now by doing resource live1 mutable test, and we see we get list, whisper, PSS, busy, foobar, etc. So let's get the first one, for example. We see when we then postfix this with period 1, version 1, then we get the first update. Now, with these updates that we've done, we haven't updated ENS, right? We've only sent chunks to Swarm, but we can still, where did that window go? But we can still retrieve it through an ENS name. So let's go to the other update version, which is multi-hash updates. Right. So live1 mutable test. Now, yeah, it's saying won't display content type application octet stream because the updates that we did were raw, and when you do raw updates, the HTTP request will have the type of octet stream. But if we do multi-hash updates, we will be able to see the page. So then we do swarm up page HTML. So let's see what page HTML is. Well, it's not much. It's background color. It's a color of text, and it's a little bit of text here. We take this hash, And we send an update request to that. And now the page content, and I can see it's HTML, right? And let's go to a URL form in the browser that we kind of recognized from before. Now we see we have, you can barely see it here. So it says localhost 85000, BCC, live 1 mutable test. It has a blue background and has a white font. Let's change that to red background and blue font. Swarm up page HTML. Now we have a new hash. We update this here. Now we see that the content has changed. Still using exactly the same ENS name. Now, the moment of truth, I guess. So this is the open cluster, or this test cluster. Right. So something happened at least. What happened was that it downloaded an older update. So the problem here is, of course, that the syncing between the test cluster and here is a little bit, sad to say, unstable still. So yeah, it's just a little delayed. Yeah. Huh? Yeah, well, I'm afraid it, oh, sorry, because this is Twist 21. Live. One, was it? Yeah. Sadly. Okay, well, that's as far as we get. So, I am out of time, or what? Yeah, so yeah, it downloads the application octet stream update from before. So it gets something, it just doesn't get the latest chunk. So I know I was bragging about that this is kind of faster than the DNS and stuff, so obviously not, right? But when the syncer will work properly and everything is up to date, this will happen all at the speed of Swarm sync